Okay, so we have a binomial probability problem here. You're asked to find the probability that a student would answer at least 6 test questions correctly from a 10 true-false multiple choice, true-false question test. If a student guesses on each question, what's the probability that the student will pass the test? So it's basically a binomial probability. The individual probability of a success at random, right, would be 0.5 because it's true false, and if you're guessing, you're gonna get it right half the time. The number of trials would be 10 because there's 10 questions, and you are looking at the magic 6 out of 10. So the value that's separating your success and failure for the exam is getting 6 or more questions correct. So we would have to add up all the individual probabilities of getting 6 correct and all the combinations of getting 6 correct, and then and then 7, 8, 9, and then finally 10, which is only one way to get 10 correct, right? So you could do that by hand, but it's a very arduous task. And it's kind of silly because in the TI calculator you have the binomial CDF I think it's called binomial CDF functionality, where you put in your size, your individual probability, and your x. Now when you do that, it'll run and give you the probability, cumulative probability of binomial distribution from 0 all the way up to your value. So if you run binomial CDF with a sample size of 10, probability of 0.5, and x equaling 6, you will get, for this specific problem, 0.6. Oh, I forgot the decimals now. Way to go. About 623. Okay, just about that. But that's the probability. So if it was normally distributed, okay, and then 6 is here. Yeah, that's this probability, right, of getting 0 right, or 1, or 2, or 3, or 4, or 5, up to 6, not including 6 or after, right? Not including 6 or after, but up to 6. So that's this probability here. So how do I find the probability that randomly you would guess 6 or more? Well, it's just a leftover, right? So we know that the total probability, all of the probabilities individually add up to 1. So to find this leftover, we would just do 1 minus the 0.623 to get 0.377 about. So that's the probability that the student will pass the test at guessing at random for 10 multiple choice questions.